Welcome back, guys. I'll be over here. I've been for a long time over. Sorry for this late. A very late upload. I'll be more consistent. Will be I'll be like this is what the field is in the process. In the next week, in the next time, I want this to be horrible. If I will reach to uploading the videos and make Facebook super fun for you guys. So that being said, let's start the video. So in this video we're going to discuss about the magnetism, electromagnetism basically. Magnetism is nothing but when it passes electric current to a conductor, the conduction material to a conductor, the arrangement of electrons of electric currents in the conductor produces a magnetic field. Okay, and that's due to the magnetic field is due to the current passing through the conductor. So the main we can say that it has principles like just characters like how at, at when there are like left hand rules and right hand rules, which will be studying it further in this session itself. So with that being said, let's move to the left hand rule. The left hand rule is nothing but when you hold your forefinger, thumb and middle finger of your left hand mutually perpendicular to each other, For example, in this figure, this is left hand rule actually. The thumb points in the direction of force, the magnetic, the forefinger points in the direction of magnetic field, and the middle finger points in the direction of electric current. Basically, it states that if there's a conductor like this, if the conductor, if a conductor is placed like this, okay, like this, okay, and there's a draw this is the conductor like this, and there's the electric current passing through it. Okay, this electric passing in this direction, and there's a magnetic, and there's a magnetic field of in this direction. Okay, magnetic field in red, magnetic field in this direction, and thus the force produced then there is a force produced in the conductor in this direction. Is right in this direction. In this direction, the yellow is the force. This one, magnetic field, nothing. This one, and current is nothing but this one from the conductor. Is the conductor, okay? This thing is the conductor, and this is the current flowing through the conductor, and this is the magnetic field, direction of the magnetic field, and this is the force produced if you pass current and a magnetic field in this way. Okay, so basically the motion, the direct current motion, the DC motion, basically works on the principle of the left hand rule. So let's move on to the working of a DC motor. Okay, so this is the working of a DC motor. It's inside motor, and there are two magnets over there. The two magnets placed so that the magnetic field passes from north to south. Okay, remember that north to south is the direction of the magnetic field. This is just the coil or the conductor of the coil. This in the yellow part. Only see this much, and these are just these strings. I'll get to it. Let's talk about how it works. Okay. Now the magnetism is in this direction, north to south. Always the magnetic field is from north to south. Okay, and electric current, as you can see, is from positive to negative. That is from here through here and to here. Okay, so it's in this direction. It's in this direction. It's in this direction. Can you see this arrow? This arrow is points direction of magnetic field. This one for another magnetic field, the electric current. This one points direction of electric current, and this one also points for electric current in this conductor. Okay, this part of conductor. So if you apply the left hand term over there, the electric current is passing through this direction, magnetism is possible. That's what I mean. Magnetic field, magnet field is from north to south in this direction. Then if y from its left hand road, then the force will be in this direction. Basically, this part is there, right? This part is gonna move up, and this part is gonna come down. And basically, if you do it more and more again, more and more often, it's gonna spin. I mean, if if you give it some time for it, it will basically start spinning, and that's how the motor works. You have a circuitry like sort of battery and wire, and these are also brushes. Brushes are nothing but they have this sketch back to brushes like this coil is there, right? And the yellow one is connected to split rings. Split rings is where they use a laser, and split rings spin actually. Split rings will spin spinning, and they're not joining. Split rings are nothing but half of a ring. They are two split rings, but they're not connected. And there are some brushes over there. This one is a brush, and this one they're carbon brushes, and they're not connected to split rings. They're touched to split rings. If they're connected, they'll rotate. They'll also rotate and break the circuit ultimately. So they're not connected. They just touch. Okay, and that's the use of brushes. They help in maintaining the circuit. So basically, this spins like this in this direction, and this torsion film, but this spins. So let's move on to the right hand rule. Right hand rule is saying that if you place your thumb, forefinger, and middle finger should perpendicular to each other, then at some points the motion of the conductor, I think that this one is there, right? This motion, the thumb points, that motion, and magnetic field. Forefinger points the magnetic field, and middle finger points in direction of induced current. I think that we'll discuss it on this one, the next topic. That's nothing but electric generator. Okay, let's 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 compare this and this, so you can get better idea of this topic on this topic. Okay, so this topic let's compare it. And motion of conductors, nothing but this conductor going like this. Okay, and magnetic field is nothing but like this from north south, and some current direction of induced current is this is the direction of current produced. Okay, I think it will be produced according to this one. It will be produced in this way. The current will be going in this way. Okay, so basically it's the AC motor. AC generator actually. AC generator is the alternate current generator. The current changes its directions. The direct current motor. So motor. This one produces electricity, and this one uses electricity to produce motion, of course, mechanical motion. This one is mechanical energy to electrical energy. Basically, these are two slip rings. They are not split, and the one side of the coil is connected to one split ring, slip rings, and the other side of the coil is connected to another slip rings. Those two are not connected to the same one. Neither do they touch each other. Okay. These are some carbon brushes which are connected to, and here in these ends we are connecting appliances, and we start glowing. Okay, basically we apply force on this side. Okay, and then when this side moves up, or basically to move, apply force on this side to move like this. So when it moves this side, and that will flip from north to south, and it moves this side, then electric current will be produced. Let me see, I'll just move this side and see this moves up. Okay, and this side, and then electric current will be produced like this, and through like this, and hence at the ends of this. Okay, there's the electric current, and slip rings are nothing but split rings. So basically, they're like split rings are half of slip rings. Okay. Things are like this for rings they in a moment. And let's go on to the DC generator. DC generator is nothing but is similar to DC motor, but it produces electricity, whereas DC motor uses the electricity for mechanical motion. Basically, there are two fixed magnets, and we are going to use this one, neodymium magnets or electromagnets. In this thing, the commutator or carbon brushes are there, and there's different commutator assembly. They help in changing the they help to rotate like that way. There are commutators and voltmeters over there, and the circuit is connected to. We can connect this circuit to a bulb. It's okay. This is a direct commutator also current. Now, some magnetic field this side, electric current will produce this. Can check that and will apply force on either this direction or this direction, and we'll find out what's the direction of the magnetic current produced on this. That's how the generator works. Okay, or we can move this axle, move this coil using some petroleum as we or diesel products as we use in our modern as we use in our modern day generators. Okay guys, that's it for today. I think we are coming to an end. So for this delay, for like if you get like over 50 subscribers and facial face reveal. Thank you for watching. Make sure to like the video, share the video, subscribe the video.